Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we look at application development and management at scale. Weaveworks is a sponsor of the New Stack. Weave allows developers to monitor and control Docker containers with zero configuration. Weaveworks is now available as a hosted cloud service. Weaveworks works with any application automatically, no extra code, no operational surprises. It's simple, scalable, and fast. Check out Weaveworks at weave.works. That's weave.works. Now let's get to the show. Hey, Alex Williams, the New Stack, here for a new episode of the New Stack Analysts. Today, I am lucky to have Alexis Richardson of Weaveworks and Matthew Lodge of Weaveworks, along with Joe Jackson, managing editor of the New Stack and my co-host for the show. Great to see you guys here at Lake Tahoe.
Squaw Valley.
Squaw Valley. Yeah, it's not exactly Lake Tahoe. Squaw Valley.
Yeah, I can see people already heading up to ski right now. It's great. Sunny on the slopes there.
Beautiful. Beautiful spot. First of all, perhaps it might be good just to give an overview of Weaveworks for people who may not be familiar with the company.
Sure. So Weaveworks is a software company founded in 2014, so just under 2 years old. We are aiming to help developers create, understand, manage microservices with containers. I say microservices because that, I think, is now the term that people are converging around, along with maybe cloud native, for the next generation of application architectures. Always containerized and often dynamically scheduled, automatically managed, basically taking the ideas that Amazon and Heroku and other great companies have pioneered and making them available to everybody in the enterprise. The microservices trend is really about people doing their IT faster. People are saying, hey, how can I be as fast as Airbnb to roll out changes to my website if I want to compete with those guys? And they're realizing that by breaking IT up into smaller and smaller pieces and letting those individual teams manage those, make decisions for themselves, they can get a lot more done. And the risk they take is that some teams get it wrong, and they're usually happy to take that risk.
I would think that most are getting it wrong. I mean, here's kind of having this discussion this week about really these companies who we're starting to see emerge, and a lot of them still come from a systems administration background, don't they? And instead of a distributed computing background. And Matthew, you and I were talking a little bit about this last night.
Yeah, I mean, it's a real challenge for a lot of organizations to adopt microservices because it is fundamentally different with a distributed system. So that's part of the challenge. I think that's what creates the opportunity for companies like Weaveworks, is that it is difficult to do, and there are things that you don't want to spend your time on as a developer. The network is one of those. One of our customers calls it invisible infrastructure. It's like that's what they want to get. So they can focus on their applications. The network just works, and it does all the things that they expect it to do. They can build out their containers, they can all talk to each other, they can all find each other, they can see what's going on, and that's the opportunity.
Yeah, I mean, fundamentally, those are the customers we care about, Alex. People who don't want to learn a whole ton of new stuff in order to adopt the new way of doing things.
Mm-hmm. So what is this intersection now that we're seeing with really developers and networking? We're starting to see much more interest from developers about not just networking but storage.
Yeah.
How and why is containers so such a driver for that?
Well, I think containers is definitely a causal factor in this. It's, in my opinion, what we're doing with containers is we are creating a kind of lightweight virtualization, which means that individual processes can be containerized, as the saying goes. And that gives you a way of starting and stopping and moving around potentially very large numbers of computers, machines.
Right.
And so that means that we're actually doing computing as we used to do in the 1970s, literally wiring machines together. And the first thing that you run into is, wait a minute, how do I do that? I don't know if you remember what it was like when networking was new. I just about old enough to remember that. But this whole idea of actually connecting two computers together was really, really, really funky, and it was really difficult. And what we want to do is make sure that every time somebody rolls out an application, when they have to connect those two computers together, aka containers, it's totally trivial and totally intuitive, and they can immediately proceed to doing things in the way they expect them to work after that, which means each container has its own IP address. You can give it a name. You can discover it through DNS. It's just like the world that you already know, familiar with, and are used to.
Wait, so how do you do that when containers are ephemeral things and they're always going to get new IP addresses from the network or from the system? How do you make that translation to make it solid for the developers but fluid for the admins?
So we are much more developer-centric than I think you realize. I think the old way of doing networking was one where admins were in charge, and with good reason. I mean, you would be given control of the whole environment inside the organization, potentially security issues, etc. You would then lay out a network across an entire organization, potentially thousands, tens of thousands of people. What's happening now is that developers are creating networks that live and die with their application. This is completely different from the old world. If I go to Amazon, I would like to stand up a cluster of machines for my application and run it for however long I need my application to run for. It might be a day, it might be years, but the point is that the network is associated with the life cycle of the application. And so I, as the developer, want to be in control of that. This is the change. So I would like to decide what things are called, when they start, when they stop, where they go, and I want that to be made easy for me and intuitive and simple. So we provide the tools with our network solution to do that, just that, with WeaveNet. One tool I mentioned DNS, but the other piece of the puzzle is IPAM, which is IP address management. In the old days, there were companies that did IPAM, big companies that you would actually go and buy a box from, and that box would tell you, how to provision IP addresses for large teams of developers in your organization, and it would all be wired up to your Active Directory or LDAP or whatever. Now, people want something lightweight and simple that lives and dies with the application. So IPAM, our IPAM tool, lets you say, give me this range of IP addresses. These are the ones I'll use in my application. So that is the level of control developers want.
I think the other thing is that being very close to the application means that you can do things that just make life easier for the application. So we try very hard, for example, when a container restarts, to give it the same IP address when it comes back up again. So there are things like that you can do that if you're very close to where the application is, you can just make life easier for the developer.
So in essence, the developer is creating their own network.
Yeah.
So that in the application, in fact, at the front end of the application is the network interface.
The application is the network, is the cluster. They're all one thing. And I was surprised when you mentioned storage, Alex, because I think storage is orthogonal. You can write an application without storage. You might be nutty to do that, but you actually can do this, whereas it's very difficult to write an application without networking.
Yeah, it is one of the big problems. I think, though, it fits in the same category of microservices infrastructure. It's one of those other, what are the common problems that people have when they're trying to build microservices? The network is the first one they run into. And then after that, they want to persist data, and they're trying to figure out, how do I do that and make it simple?
Yeah.
Part of me is maybe a little bit confused, I think, because we're hearing so much about software-defined networking, right?
Yeah.
And we hear about software-defined storage. And I think, if I'm going to kind of make some kind of jump, I would kind of associate software-defined storage then also with container processes. But perhaps I'm not really thinking of this the right way.
I don't have an opinion on that. I mean, Luke Marsden from Cluster HQ is the right guy to talk about this stuff. It's an interesting area of technology for sure. But I think I would observe that software-defined storage was a terminology that was invented after software-defined networking. So it was a kind of borrowed term from SDN. And SDN was invented by academics to give you a way to separate the management of the so-called control plane from the so-called data plane and program your network. So that came from fundamental concepts, whereas SDS, I'm not sure, did. I think it's just...
Right. I think that we hear more about the kind of in the context of volumes, right?
Yes.
More than anything in the storage space. But getting back to your guys' philosophy about this new thinking about networking, in which the developer is really kind of putting all these pieces together. What's your philosophy for for the approach to take?
Well, there's two approaches you can take if you want to help developers, and we want to help developers. You can give them a PaaS, or you can open up the guts of the application. As simple as that. If you give them a PaaS, then you are saying to them, if you buy into the assumptions that we are making about how your application is constructed, then we can help you. We are an opinionated construct. On the other hand, if you want to help developers without presupposing an application architecture, or without saying the application has to be a 12-factor app or this kind of app or that kind of app, then you need to expose the guts of what's happening inside the system much more. And so we're seeing an emergence with the latest tools like Kubernetes, Docker, Mesosphere, CoreOS, Weaveworks, HashiCorp, etc., of a class of tools that aim to help developers move forward quickly, but exposing more of the machinery than before. So this is the goal of, how do I achieve what Heroku did for the developer, but for a really wide class of applications that aren't necessarily, Ruby web apps running on EC2, but one of the other kinds of apps that you would have to run. So the decisions that you make as a vendor are crucial. You're trying to find out, how do I expose just enough of the networking concepts to developers that they feel are in a world they understand and can get things done in, without without abstracting so much away that they actually have no control.
So what do you open up?
Well, basically, what we think is the right thing to do is computing in the 1970s. You give them IP addresses, you let them look up names for services on DNS, and you give them IPAM, and that is enough to build a cluster. And that seems to be the model that people have converged around with Docker, with Kubernetes as well, and with Mesosphere. That's the way to do it. But this means that you're not actually, you stop doing a whole ton of things that you expect to find in an enterprise class SDN. Those are things which you might see in VMware NSX, for example. All kinds of management interfaces for policies and control. These are important organizationally, but for the individual developer just getting started building their app, they just want to get to a cluster really fast. They don't need to worry about that stuff. Do you see what I mean?
So how do you guys coexist then with other network environments then?
You thunk into them, if that's what you do. So there's...
Thunk into them.
Yeah.
I like that phrase.
Well, it's an important part of adoption. So International Securities Exchange, talked publicly about what they're doing with containers and CoreOS, and they're a Weaveworks user, and for them, their market data application sitting in their data center, it's not going anywhere. The new things that they're building on containers have to be able to talk to that, and so they use Weave Network to connect the two together. Right, so they can multicast their market data feed into their application. So you've got to bridge the two worlds. You've got traditional network where that market data application runs in a traditional data center, and you bridge that into the container world. And so the integration of the two and making the two look the same is super important for them.
So what does Weaveworks offer for the network administrator? It sounds a bit horrifying, having developers run around using up all my resources.
Well, because it's an overlay network, it makes your life a lot easier as a network administrator, because you can administer in exactly the same way you do today. You've now got this sort of app-level network that's running on top of that. So you still have the same level of control that you had in the past. You can still do isolation and all those other things you wanted to do.
But you just need to worry about capacity planning and making sure you're staying ahead of the app developer needs.
Yeah, I think the other thing is, we chose VXLAN for the encapsulation between hosts, and one of the reasons to choose that, network administrators are very familiar with that. It's a standard protocol. All of their packet sniffing tools know what it is. They can look inside the packets and see what's going on. And so again, we try to just fit in with what everybody already has and is used to using.
Nice.
So what's the latest then with what you guys are releasing? Yeah, I did see one of your most recent blog posts about WeScope, and it looks like there's some new things in there. One of the things that I did see, kind of like one of the kind of patterns I see, kind of like in Weaveworks, is like this idea of visualization, right?
Right.
And this idea of illustrating for the user. I mean, you actually talk about you can actually hang this on your wall, like making kind of a joke of like you can take this visualization and make art of it in some respects.
That's right.
Some people have done that, Alex.
Have they? I would love an art piece from you guys.
There's a gentleman who works in Vietnam. He's actually American. Who's done that? Yes.
Oh, excellent.
With his 1700 node network. It's quite something.
It's like the new macrame or something like that. So this raises some interesting questions, because whenever you start talking about visualization, you're talking about what information do you actually surface, right? What is most relevant to the user? And this is people would consider this an art form in itself. I'm curious on what you guys' approach is. What is it that you're thinking about, and what you do illustrate?
Whereas with the networking, we're trying to just remove blockers to applications. As Matthew mentioned, enabling multicast in the cloud has been a long-standing blocker for people. We do that. With visualization, we're going much further than that. We're actually trying to create new value. We're not trying to remove blockers so much as actually help developers understand WTF is going on in their application at any given time. And what we found in talking to customers is this. They're like, my boss says we should do microservices. We are going to adopt these tools because these are the ones that we've read about on the new stack, usually. And we're going to then show the boss what is going on in this new application we've written using these tools. And then how do we do that? We can either do that using command line demos, which the boss will go nod politely and say, that looks great, guys, carry on. Or we can show them the whole application. And what we've tried to achieve fundamentally with WeaveScope that is so important is we want developers to see on the screen the application as it exists in their minds and as it exists on the whiteboard. This, we think, is the fundamental enabler to actually getting to grips with what is going on in your application.
That's the fundamental philosophy then.
Yeah, absolutely. So just as with the network, we're trying to help developers to move forward. Here we're trying to help developers to actually understand what is going on in their application. And that's different from traditional ops world, where you're trying to gather metrics and aggregate them and plot them.
How's that different?
So I think maybe I can illustrate this with a story. The old way of doing monitoring used to have an ops team run by head of operations, and they would be given applications by the dev team, who would then do their best to get out of the way, disappear, maybe go on holiday or something. So you'd have this concept of putting an app over the wall into the operations team. Now, with microservices, operations and development are no longer two teams. They've been merged into one huge mega team and then re-split into lots of tiny microservices DevOps teams. So, for example, a company that we've spoken to, but it's sort of reasonably public about their numbers, is Yelp, although Cockcroft does a lot of talks about different companies and their numbers, but Yelp is a good example. It's got about 500 developers. There's about 50 teams. Each team is about 10 people on average, obviously, looking after about 300 microservices. So this is a different way of splitting up your IT. Instead of having dev and ops do monitoring and dev do development, you now have lots of little DevOps teams doing microservices, and you have the philosophy of if you wrote the code, then you own it in production in all of those teams. This is a new thing which has come along with DevOps and microservices, that everybody is responsible for understanding what's going on in the application. And this means that the way that monitoring surfaces in terms of production situations is different, because now the user is a developer who's doing an operational role and not a traditional operations person. A traditional operations person will have a list of alerts they're watching for. They'll be saying, when disk capacity reaches X, that's when I might need to have a new machine. When my network bandwidth is clogged up to here, that's when I might need to provision some more or dial down this application. When CPU on this node reaches X, that's when I need to maybe get a new machine. This kind of thing. Now, a developer, when they see an application and they're seeing alerts coming through, will probably not immediately believe them. They won't take the numbers as a fact. What they'll want to do is they want to interrogate their application and verify whether or not what they see on the screen is happening. So an example would be, I'm running 4 MySQL servers for my web app, and there's 2 active passive pairs, and then my screen says I'm running only 3, but I thought I was running 4. Now, do I believe the screen? What a developer will immediately do is they'll open up a console, SSH in, and they'll start interrogating the system to find out whether or not there really are 3 or 4 servers running. So this is a very different way of interacting with your system. Developers expect to be able to ask questions of the system and not take the data at face value, which means that you have to have a different kind of monitoring tool for them. Not only must it show what they expect to see, but it must enable them to ask questions of the system directly.
Now let's take a quick break before we get back to the second half of the show. Weaveworks is a sponsor of the new Stack. Weave allows developers to monitor and control Docker containers with 0 configuration. Weaveworks works with any application automatically, no extra code, no operational surprises. It's simple, scalable, and fast. Check out Weaveworks at weave.works. That's weave.works. Now let's get back to the show.
How are implementations coming along? Do you have any early users that you can talk about?
Matthew mentioned International Securities Exchange.
Yeah, that's a very interesting application for them. I mean, they're essentially shard their application, and they multicast the data feed to all the different shards and process that. I think JP Morgan Chase have been posting their scope screenshots onto Twitter recently.
Oh, nice.
So they're basically building out their own PaaS based on containers. So that's another good example.
Yeah, and just last week, Cisco started distributing Scope with their mini Mesos distribution in Mantle. So Ken Owens, I think, is at this conference this week, is using Scope to show users how to debug the applications that are running on Mesos with Mantle. So these are cool use cases.
Excellent.
So you guys, you mentioned CPU usage, and one of the things you did in WeaveScope 0.13 is you reduced the CPU usage by 75 to 85%.
Yeah.
This has to be one of the big issues, right? I mean, that developers are facing. Or
it's the Heisenberg principle. Everything that you touch, you interfere with, you mess with. How much CPU load are you willing to take in order to get the benefits of virtualization, monitoring, what have you? That's the challenge. So we're trying to get that to the right place.
Right. So it brings questions to me about loads and and the distribution of loads across these distributed environments. One of the things we're interesting to look at it when you're looking at kind of orchestration environments like Kubernetes. The issues people are starting to talk about things like memory mapping, and I/O patterns, right?
Right.
And how do you guys approach those, those issues? Kind of that removing. And I ask because we're moving into this world of container orchestration. It's quite like kind of almost like this black box. You're starting to see these kind of issues crop up. How are you thinking about managing the memory, right, and managing like I/O patterns?
I thought we were in a world where people didn't want to do that, like JVM and things like that.
Yeah, I mean, a lot of our customers, that stuff is actually getting less important now because it's more about the aggregate behavior of a group of containers, a group of replicas that implement a particular service, which may or may not be running on the same host.
So is it more an issue of the scheduler and then the service discovery,
service
and the service management?
Yeah,
service management.
Yeah, I mean the schedulers are obviously trying to be solve the bin packing problem as best they can, right? And there's different efficiencies for different schedulers. But again, a lot of our customers don't want to have to think about that.
So going back to what you're talking about mini Mesos, tell us a little bit about that.
Single machine Matthos for developers, created by Cisco and Container Solutions in partnership. It solves a problem for the Mesos user, which is how do I try out Mesos without deploying 10,000 machines?
Interesting.
Yeah, how do I get started easily? And that's a common theme for Weaveworks in general, is we try to make it as simple as possible for people to get started, even with complicated things. So and we did the thing Kubernetes anywhere. It's like a one-click install of Kubernetes. Same principle. Like, how do I get Kubernetes up and running very quickly so I can kick the tires, figure out, is this the right thing for me? Learn about Kubernetes. And we essentially use WeaveNet to bootstrap that thing, so that you can bring the whole thing up very quickly. And it's also very portable. You can deploy it to different cloud networks, or different clouds, and even if they have different networks. And that's a super important thing, because we're still at the stage where everyone wants to experiment. They're trying to figure out what the right answer is. Brian Cantrell from Joint, says it doesn't think we've reached the point of peak confusion in containers yet.
Right.
I think he might be right about that. So anything that we can do as a philosophy of approach, anything we can do to make it simple is going to help people get the experience they need, make the decisions, move forward.
Also, testing.
Yeah.
It's all very well talking about trying stuff out for the first time, but there are actually people doing this stuff in production as well. But they don't solely exist in production. There's a cycle that feeds production, dev, test, some sort of UAT, and it loops around. Every time they want to make a change, they have to retest and revalidate those changes. So the ability to stand up, whether it's a Matthos cluster or a Kubernetes cluster or a Docker cluster, really fast, really easily, anywhere, and then see what's going on is profound in terms of enabling those developers to make that cycle go faster. It's not trivial stuff.
No.
You also want that repeatability, right? What you deploy in dev, you want it to be the same when it goes into test, and you want it to look the same when it goes in production. So that's the other important thing around.
And how do you know?
Yeah, how do you know? And how do you make sure that, dev might be running on your laptop, test might be running in a cloud, production might be running in your own data center. And so also that's the other thing about network portability, is making the network be exactly the same, regardless of where it's running, is super useful for that.
Yeah, if you run an app for a few days, how do you know it's the same app as it was when you started? You don't. You need a tool to help you. Things like memory mapping are just too low level to explain this. So, okay, I'm now using 7 XYZ of RAM instead of 6, so what? Is my application the same? That's what I want to know. Is it happy? Do I need to give it more stuff?
So this goes back to what you're saying about the developer only needs to know so much, right? It's like what you want to open the guts of you want to open the guts a little bit, but you don't want to expose.
This is what developers want. They want to see things as they see them in their heads. And then if they don't see what they expect, then they want to drill in. And then they want to drill in as far as they can, ask any question they like.
And so that fits into many Matthos and why you would work with, develop something like what you did.
Well, we want those developers to be able to, for example, let's say they're running a Matthos cluster in production and they see a fault. How are they going to test an assumption about what may be wrong with their application? If they can stand up mini Matthos on a single machine, they can now ask that question on a single machine on their laptop really quickly and really easily without having to go, wait a minute, where's the Matthos dev cluster? Let's provision that. That is a sucky way to do things. It's much better to go, okay, I think I know what's wrong. Let me try it out on my laptop.
Right. And these are experienced. You go into the Marathon console, you can see the task that is running. You're like, well, great, the task is running. But what does it really look like? And so that's the advantage, like asking those questions about, okay, is this thing working the way I think it was supposed to be working?
With Scope, you can also interact with the application, so you can actually stop the task. You can say, wait a minute, if I stop the task, do things still behave nicely? Stop. Now I look at it again, and now I start it again. Start. Simple.
So you were talking a little bit beforehand about Flux.
Yeah, that's a fairly new thing. What we realized is that people are keen to do microservices, but don't necessarily want to set up a whole orchestration platform to do that in some cases. We are totally endorsing the use of these platforms, by the way, but also there are people who just want to have a fragment of what those things can offer. So with Flux, you basically get a way to assemble a microservice. It's a microservices router, or as they say in the States, a router. You can also call it a broker if you like. So you can stand up a number of instances of your service, for example, your MySQL instances, and then in front of that you have the router, which then determines how to flow traffic to the instances based on what you tell it. There's other things in the market that do that. The most obvious one is something called kubeproxy, but that's part of Kubernetes. You can't run it on its own. There's also things like Linkerd is a new thing from Buoyant. There's a thing called Vulkan D, which is based on etcd. all these things end in D, which we thought we wouldn't do.
Speaking of the low-level kind of things, it seems like, with the CNCF emerging, right, the Cloud Native Computing Foundation,
Right.
part of the idea behind that just seems to be providing those users with a programmable infrastructure, essentially, that allows you then to run, I guess you could describe them as integrations, right, where you could run Kubernetes, you could run Matthos, you could run it with any with different tooling and such. I mean, I'm just trying to get my head around what CNCF is right now, and it seems like, I always go back to the philosophy really is let's put all this really complicated plumbing underneath the covers so that the developers can actually use this stuff.
Yeah, I think if the CNCF is going to be successful, what it needs to be able to do is help developers, help the users or the customers of the CNCF get to cloud native architectures faster and more simply. I think that's what success should look like for a CNCF. And then to do that, as part of doing that, the CNCF is going to have projects, right? So you're going to have reference implementations, if you like, for a lot of the concepts that are part of cloud native. So one of the things that CNCF can do is make sure all those things fit together and they work together as a coherent whole, like architectures about, here's how you build these things out. But do that in a way where you're going to have things like Kubernetes in the CNCF, right? That's the first project. But without requiring everybody to go run Kubernetes if they're going to do things the cloud native way. So it's also about architectures as well as about code.
So you're the chair of the Technical Oversight Committee.
Yeah.
So what are your mandates?
Our mandate is to select projects for the CNCF, to decide what it means to be a cloud native project, and make sure that the foundation is providing for developers what they need from a foundation, which has changed from the 1990s. So it's essentially a modernization of the Apache concept. Apache was started at a time when people didn't have access to mailing lists, software repositories, and so forth. Now they do through things like GitHub and Gmail and so on. But there are other things that developers want. They want large-scale testing, for example. So one of the things the CNCF has done through the generosity of one of the platinum members is obtain permanent access to a very large-scale cluster in, I believe, in
it's in SuperNAP, yeah. So this is Intel. Let's give Intel a plug because they paid for this thing and like that. Yeah. So it's at Switch SuperNAP in Vegas.
Yeah. So if one of the frustrations of being a customer or a vendor is how does this stuff scale? And we're going to be making sure that people can answer those questions. So that's the kind of basic service that a new school foundation can provide for projects. As Matthew mentioned, there's also architectures, recommendations, guidance. We want customers to not feel confused and intimidated. Quite the opposite, to feel easily able to proceed quickly.
Are they confused and intimidated?
Well, they are when they have to decide which technology to choose. That is always a difficult choice, and the bigger the company, the more difficult the choice is, because you always have different opinions.
We see that with the container orchestration market.
Very much so.
Yeah.
I mean, that's the hot spot for that right now.
Mm-hmm.
But there's so much more to it than that. We were talking earlier about visualization and networking, but there's also things like storage. There's lots of logging is another good example where people are asking questions. Should I use Splunk for my container logging? The CNCF should be able to identify open source projects that actually can help with logging for containers and promote them, and then customers can see that those are good projects, and the CNCF should encourage those projects to, if they can, interoperate, which means that customers know that they can actually use these projects together. This is very important to people, rather than doing it themselves.
Now, yesterday we heard that etcd might be the next CNCF project.
That is true.
Could you talk a little bit about why this project is important for the foundation?
One of the patterns that you see in cloud-native architectures and microservices is the use of key value stores to provide synchronization between different components of a distributed system.
Mm-hmm.
So, for example, if you want to determine who has the right to access certain systems across a large organization, you might update, in the old world, you'd update a database. In a world where you want to update a database but have it work in a distributed setting, you would probably replace that with something like a raft-based distributed key-value store. That's why technologies like Zookeeper, etcd, and Console are getting traction in this space. So that's a common pattern. So we believe that there should be a distributed key-value store inside the Cloud Native Foundation. That's one reason why etcd is a suitable project. Another reason is that etcd is a project of quality. It's not a brand new thing that is totally, poorly written. It's something that's gone through a number of iterations and proven itself in battle. And finally, let's not beat about the bush. Kubernetes depends on etcd. And if we have Kubernetes in the foundation, it's got a critical dependency on etcd. That should be in the foundation too. As it happens, the Khoros guys are very supportive of that goal.
Yeah, well, they're the chief ones behind it.
They're the main people doing etcd, that's right.
Right. And etcd, how does it play with Matthos? I have no idea.
I think it plays fine with Matthos. Yeah.
And
Docker use it too.
to switch the question around, what will the foundation offer to the etcd people, etcd developers?
Well, I mentioned the cluster. I mean, one of the things that I went to KubeCon in London not very many weeks ago, and I saw Brandon from from Khoros, the CTO, talking about these things, and he was talking about etcd specifically. They're launching version 3 right now, and they wanted to show how they had reduced the number of certain types of rather strange errors that people had seen with version 2 of etcd. And in order to actually track those down and fix them, you do want to do some pretty serious testing. So one of the things that Matthew mentioned, SuperNat cluster provided by Intel, will lower the cost of testing for etcd and mean that customers benefit because they, this is a really tested piece of software.
Nice.
So take us through the process then about making etcd a priority. What happens now? etcd being a priority in the CNCF.
The right thing to think about is, if you want to look for something else in the world that looks like what the CNCF wants to be, look at Apache. Okay? Apache is different from something like OpenStack because OpenStack has committees which determine an overall single architecture for an OpenStack cluster. I think they're loosening that up a bit now. But I think that leads to quite a lot of that slows development down. What's good about Apache is that individual projects can proceed at their own speed, moved by the users, the customers, the developers around those projects. So what should happen with Cloud Native Foundation is projects don't slow down. If anything, they speed up. So in that sense, we want to be like Apache, and there will be multiple projects inside CNCF. It will not try and pick winners. There might be cases where two projects overlap in functionality. We see this with Apache as well. It's a healthy situation. Over time, the market either determines there is a need for two projects or might merge them, push them together, as happened with Ruby on Rails and MERB a few years ago. So we want to encourage that too, because what we don't want to do is premature standardization. Premature standardization is a mechanism for discovering areas of disagreement, typically between vendors, and then amplifying them in order to, roadblock around some political problem. What we think is important is for standards to emerge through actual use by customers. So one of the things that's also cool about the CNCF is we have an end user group representing the voice of those users who can actually determine what's going on. Does that help?
Yeah, it does.
Yeah, I think personally, what I'd like to see is be like the IETF in the early days. The sort of rough consensus and running code was the byword, was the phrase they used to when they were trying to get started and get all these different networking things interoperating and working together. And they had vendors, at each other's throats. Huge competition between vendors, but in the IETF was a way of essentially working through all those differences, not picking winners, finding ways for these things to work together. I think if we can achieve that, then I think we'll be in good shape. I had a gentleman come up who actually was on the IETF in the early days. After I did a talk about this at at a show, and he said, "Well, it's not quite the way you talk about it. It wasn't quite like that." but
Yeah.
I think the spirit of what they were able to achieve is something that we're shooting for with CNCF.
The pace is different, for sure.
Yeah.
Well, thank you for taking some time, Alexis and Matthew, and participating in this episode of the New Stack Analysts. Joe, thank you for joining us today. Enjoy the Collab Summit here in Squaw Valley, and we'll talk to you guys real soon.
Great. Thanks, Ollie.
That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor. Weaveworks is a sponsor of the new Stack. Weave allows developers to monitor and control Docker containers with zero configuration. Weaveworks is now available as a hosted cloud service. Weaveworks works with any application automatically, no extra code, no operational surprises. It's simple, scalable, and fast. Check out Weaveworks at weave.works. That's weave.works. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.